Okay, so welcome. And now we're going to do this example here. We're going to show that these two vectors in this set are linearly independent. Okay, so what we're going to do is we're going to set up a linear combination, a linear relationship, right? So the way we're going to do that is we're going to do C1 times the vector 40, 15. So these are row vectors, plus C2 times negative 50, 25 equals 0, 0. So the system that we're going to end up with is C1 40 C150 plus C2 negative C250 plus C225 equals 0, 0. So now, how do we do this? Well, we got this plus this equals 0. So we're going to have C1 40 minus C250 is equal to 0. And then we got this plus this equals that, right? So we've got C1 15 plus C2 25 equals 0. So now we've got that system of equations. Okay, and of course we can write this the normal way we would write things. So we'll just put the constants in front. So it'd be 40C1 minus 50C2 equals 0, and 15C1 plus 25C2 equals 0. And so now we would solve this linear system, right? Using the eliminating row reduction, right? And so when we do use that, what are we going to do? We're going to take negative 15 40ths plus this. So negative 15 40ths row 1 plus row 2. And so that's going to give us what? It's going to give us 40 C1 minus 50 C2 is equal to 0. And then what happens to the bottom one? Well, C1 disappears, and we end up with 175 over 4. Equals 0. Right? And now we see automatically that C2 is equal to 0. And if C2 is equal to 0, well, this is equal to 0. And then we get 40 times C1 is equal to 0. So C1 is equal to 0. So we get C1 is equal to C2, which is equal to 0. And therefore they are linearly independent. Okay, cool.